So thank you for the introduction. Mark already introduced the chatbot and me. So basically, this was done. Some parts of it were done already in 2012. So the user interface, which I'll be showing, and some parts of it will maybe seem archaic, but the approach is relevant still today. Nothing like there is nothing. It's still state of the art. So far, nobody did this approach yet. Based on the knowledge, so it's not based on patterns or textual patterns or machine learning in the statistical sense, but it uses its knowledge-based approach. It's based on the psych artificial intelligence, which I will explain quickly as well. And the whole idea of this chatbot was not actually to become a chatbot, but to be able to teach a computer. So to be able to teach a computer what we know, and then use this knowledge. So and then the computer could use this knowledge to start learning on its own. And it did that by asking questions. So maybe to quickly introduce Psych. So it's a big AI system which started in 1984 when they figured out in the first AI winter, when they figured out that there is no shortcut, that in order to make computers smart and make them understand the world as we do, we need to teach them the concepts we understand, and there's no shortcut. We need to do them step by step, one concept, one by one. And Doug Lehnert, the founder of Psych, started doing that first as part of the research project, and then then he founded a company, and it continued to survive the second AI winter. And in 2013, they had 500,000 concepts, 50,000 of relations, and more than 10 million of logical facts encoded in first-order logic in this big database, knowledge base, or ontology, however you call it. And so far, there's no, like the machine learning, current machine learning approaches, they're still not there yet. So as an example, how this knowledge base looks like. So they started by introducing a thing, which on itself is a thing as well. Then they added a concept of the universe, which is a thing as well. And celestial body is a thing as well. And the universe is located, the celestial body is located in the universe. And planet is a subclass of celestial body. And Earth is a planet. And then we have animals, humans, money, chemistry, and all sorts of human common sense concepts. And this is kind of the schematics we get out of these 30 years of work of hand-by-hand encoding of human knowledge.
You see how AI God creates the world, right? In 7 days or 7 minutes.
Yeah, slides was a few seconds, but the actual work was more than 30 years now, I think, and quite a big financial investment as well. So basically, it tries to encode all the aspects of human knowledge, and then there's some place for about specific domains. When you want to use that, of course, it doesn't cover everything, so you need to add some domain-specific knowledge when you build applications on top of it. So yeah, these are the kind of textual examples of what could be or what is in this common sense knowledge base. These are things which we don't normally think of putting into the computer when we want to do some applications, like just domain-specific applications, but actually sometimes we still do need it, surprisingly. This is an example, so it's based on the terrorism domain because at some point they had a project with the army, so there's a lot of concepts about terrorism inside. But yeah, basically this is the English representation, English statement, and this is how it's converted to, this is how its logical representation look like. This weird language is called Cycle, and it's basically just a syntax for first-order logic written in a little bit Lisp-like way. This system can do translation from English to logic as well, and from logic back from logic to English, because all of those concepts, besides their own meaning and they're also attached to the linguistic concepts. Basically, every concept you can find in the database also has concepts about the language, mostly English language, the words it can be used to describe it, and some rules about how those words can be used to generate as English sentence.
Maybe it's worth saying here, right? So this actually operates automatically. So we have this piece of text automatically gets translated into logic, right? And well, then we can do reasoning with logic, and then whatever logic we have, we can translate also back to text. So this kind of simple sentences we can do automatically. Complex sentences not, but this level of sentences works 100% automatic.
Basically, these were the basic building blocks we used for to form a chatbot. So this slide represents how an intelligent agent, not only chatbots but also humans, kind of learn. So the more knowledge you have, the faster you can learn by discovery, because the more you know, you're kind of faster to discover new things. Then you can use natural language, where you can see that initially you cannot learn much because you don't have any vocabulary, so you don't understand what people are saying or what the books are saying. But once you pick up a little bit, it really goes up quickly, up until at some point, which is we call frontier of human knowledge, because you cannot really find any book about the knowledge anymore, or nobody can tell you anything. You just need to switch back to learning by discovery. You can still do research and figure out something. Then the approach which Psych did, which I already mentioned, was to codify and enter everything by hand. And this is kind of flat. It's not growing. The more you know, faster it goes. But it's kind of higher or lower depending of how many people is doing this, how much funding you put in, how quickly you can type, basically. And they did this for 30 years. So, and it took more than 2 million of investment. 200 million of investment. And I think this slide is a little bit old, so now it's 45 or 36 years already. And the idea of our chatbot was to start using natural language, and instead of using this flat line, start to really quickly learn new things. That's a short architectural slide. So basically we have users with the phones. We pick up some context from the phones, like locations, some sensory data, and some classifications, which I will explain later. And then we have a rule engine, inference engine on top of the knowledge base, which I showed before. And then we had some special inference rules which dictate what the chatbot wants to learn, or how the approach it uses to learn. I will show an example of that as well. And the API which applications can use. So basically, user provides the context and maybe a question, and then the system provides an answer. Or the opposite direction work as well. So basically, machine can ask a human. It uses the logic to figure out what it needs to ask, converts it to English, and it can ask humans a question. Then human answer it. Then it goes into other direction as well. Human can ask a question, and the machine will answer it. But sometimes it doesn't know the answer, so it just forwards it to the person, which kind of thinks he will know the answer, and then the person can answer the original person the result. So this is the contextual information which I mentioned. It was fed into the system. Basically, this is my historical feed from GPS feed from the phone. We can detect how long and where user stayed for a while, and if you follow the user for a little bit longer time, we can do also the predictions. So in this case, I was in some conference, and the system learned that there's 100% of chance I will go to McDonald's in 20 minutes. So basically, that's the contextual data we were feeding into the chatbot. So it used this knowledge to ask better questions. The initial versions were able to learn new instances, new concepts, the relations kind of, and for the rules we only did some simple experiments. We never finished it. So this is an example of the inference of the which triggers the questions. So let me go back. So basically this is a logical rule which says that if there is an organization so there actually not is missing here, and it's not known who is the head of this organization. Curious Cat, so the system is called Curious Cat, wants to ask about who is the head of this organization. And this is then picked by the inference engine, which can generate intents for the chatbot what to ask. So basically, it serves as a intent or like wish for the system to actually ask questions and learn new things. And this is the example of one question that it comes up with. Basically, it figures out that there's a Jožan Stefan Institute is an organization, and it doesn't have the person, it doesn't know who is the head. And it produces, okay, see it here better. So yeah, it produces this natural language pattern. So in this case, it's not formed as a real question because of the setting we used, but basically it can generate this in the interrogative mode or in declarative, like here. And so in this example, then somebody answers with the Jadran Lenarčić, who is the head of JSI, is the head of JSI, and the system not only learns that, but it also implies that Jadran Lenarčić is a person. So this kind of shows why it's useful, beneficial to use inference engine, not just some sort of textual patterns. With those patterns, you could only pick up the head, but not that the guy is also a person. This is another example where it came up with a question. So I was visiting a bar, and it knew that I was a person, and there was an event of the visiting a bar, and then it came up with the question what I had on this visit of the place. So that's the actual interface of the chatbot. I answered that I had strange coffee, which then got put into the knowledge base on the place of food or drink, because it knows that I can only have food or drink there if I order it at the place. But we could actually do better by positioning it here, which we do in two ways. Either searching the text, and we see that the coffee is mentioned in the answer, and then we know we should put it under the coffee, or we ask additional questions. Is it a food? Is it a drink? And then slowly bring it to the right place. So in this case, it wants to confirm whether its thinking was correct, and it asks me more. It doesn't know the concept, okay, what is it, but it already provides the information about what it could be. Then our idea, so basically this was done as part of the startup, which was never successful. It also never really died. So, but it stayed as a research project at Jožef Stefan Institute. And our idea was to make this into an assistant which is really understanding what users tells it, and then users tell it, and then it's able to use this knowledge to help users and to help another users as well, because the knowledge was shared across every user. This is kind of easier to show on the demo, which is more like screenshots from the app, because we turned it off now, but I can still show this, how everything was constructed together. So basically I was at Lerdois restaurant, and it asked me whether I'm there just to confirm. So the context of this came from the GPS coordinates, which I showed before. I answered yes, and then it wanted to know what kind of place it is, because it uses inference. It already kind of tried to guess what it could be, so it put the suggestions onto this bar which you can click. Then, because it figures out, okay, I know at the restaurant you can have music as well. It asked me, basically, on each new answer you provide, the inference engine produces maybe 10 or 15 or 20 possible questions, and then it picks one. And in this case, it picks one about the music. I answered that there's techno ambient. It didn't know what that is, but it figures out it must be style of music if it was there. Then it asked me what I had as an example before. I said traditional duck. It figures out, okay, I don't know that, but it could be one of those things, which was duck meat. Then it asked about the cost, which kind of cuisine it has. I answered with French. And now, here, this is, sometimes it paraphrases it back just to see that it actually understood it. So I entered, it's a French cuisine, but it came up with the French food, like paraphrase back. And then another thing, because it actually understood what French food means, it asked me whether they have baguettes or not. So this kind of shows the understanding that was that was possible to be done by using the knowledge base and inference engine. You cannot do this just with the patterns, and also not so easy with the machine learning that we are doing like lately. Another example was, it was asking whether it's a live music venue, and then I entered some more answers about that it is and what kind of music is there, and that there's an event at particular date. And then there is another user which like independently was talking to the Curious Cat, and he mentioned that he likes jazz music. And then the system already, based on my knowledge, suggested that he should maybe visit there, go there and check it out. That's another example that was basically done as a based off like it scanning all the knowledge that it got from me, and then when I asked it where I should maybe go to it came up with some suggestions and also the explanation. And this is actually done by inference engine, so it's a real logic-based knowledge just converted back to English, and it also explains why it means, why it thinks this is the good result. Just to show how it can combine the knowledge from different users, there's another guy who said he likes French food, and because I already answered about this restaurant, he can click on it and see all of the knowledge that Curious Cat knows about this place. So this shows that this can be shared. And now another thing which we built in was, because I could be lying, the system was trying to check with different users whether the knowledge somebody else or me in this case entered, whether that's correct or not. So if he would say no, the system would just remove this knowledge into some, not really remove it, but put it back into the maybe knowledge and not showing it to users. But in this case, he confirmed it, so the more confirms it got, the more like the probability of it being true was higher. We ran that as an experiment, so it was online for a few years. And during the experiment of 2 years, we were able to actually get almost 400,000 of new logical statements, where 56,000 were directly asserted by users, so direct answers from the users, but the rest was actually picked up by inference engine, as the example before, where some user said that who is the head of JSI, and then the system inferred that he is a human as well. So there was actually 340,000, almost 340,000 of inferred knowledge based on the knowledge that users provided. Based on that, so from this, what users entered, it was 8,500 of the items were shown to different other users as well. And most of them were approved, but some of them were also rejected because they lied or they didn't know or they answered something weird. Yeah, that's again an example how you can get what the system thinks about the Roger Stefan Institute. It's just so one of the users entered something. And another thing maybe about the disambiguation. So here the user was interested in meiosis. Meiosis, I don't know how to say it properly, but because it could mean two things, it actually asked which one do you mean? And then one of them is actually the poisoning, and another one is the cell cycle phase in the offspring production. This is not relevant anymore. It used to be on Google Play. I removed it because of GDPR, because we stopped developing it. But if somebody is interested, I can still give a demo or provide some more information on that. Thank you.
Thank you.